Lesson 3.4, we are getting into triangles. Is everyone present today?
Yes, ma'am.
Aaron Shamp is absent. Okay.
Section what is this?
Section 3.4.
Do we need to take a picture?
Yes, you need to follow along and take notes. Okay, we're going to talk about triangles and the relationships that exist within one triangle and between triangles. We're going to discuss a couple of corollaries and a theorem today, and then we're going to go over some problems to help us
What is a corollary?
apply the things that we've learned.
What is a corollary?
Well, Josh, let me be very specific for you, even though this has nothing to do with anything. But a corollary is a statement that can be proved easily by applying a theorem. Okay? All right.
Which doesn't exist.
In a triangle, it is a three-sided figure. You have things called vertices, is the plural form, or vertex. The vertex are the corners of the triangle. Okay? So, the definition of vertex, which is what you need to put right now, is
Corners.
the points, or the point where the sides of a triangle meet. The point, or points, where the sides of a triangle meet. In this particular triangle, we would call it triangle ABC. We use the symbol triangle, and then we label the three vertices of that triangle. Okay? What are the three vertices of triangle ABC?
A, B,
Point A, point B, and point C.
Point A,
Not right.
point B, and point C. Not angle A, angle B, and angle C. Because a vertex, what was the definition?
The point on
It's
the
a
sides
point.
of the triangle.
It is a point. It's not an angle, it's a point. Okay? The sides of a triangle are the line segments forming it. So the sides are line segments that are joined to form the triangle. Now it's important to say line segments because if you're asked to name the sides of a triangle, you have to name properly those three line segments. Name one side of triangle ABC.
AB.
BC. Segment BC. What's another one?
AB.
Segment AB. What's another one?
BC, sorry. AC.
Segment CA. Those are the three sides of the triangle. So, we've got to know specifically a vertex is a point and the sides are segments. So that if you're asked to name them, you will name them correctly. Moving on. Okay. Now we're going to classify triangles according to the relationship of the sides. S-I-D-E-S. And there are three words that are used to represent the relationships of sides of a triangle. Scalene. A scalene triangle has no congruent sides. A scalene triangle has no congruent sides. That means that each side has a completely different measure from all the others. None of them equal each other. That would be an example of a scalene triangle. There are 3 sides, and none of them are equal to any of the others. An isosceles triangle is a triangle with at least 2 congruent sides. At least 2 congruent sides. And the picture I have there of triangle ABC is an example of an isosceles triangle, where AB is congruent to BC.
So would an equilateral triangle be an isosceles triangle since it's at least 2?
Yes, ma'am, it would. Very good. You beat me to the punch.
Wait, what?
Just wait, I'll get there.
Wait, what'd you say?
We'll get there. An equilateral triangle. Equi means equal, lateral means sides.
All sides are equal.
All sides are congruent. In an equilateral triangle, all sides are congruent. Equilateral triangle, 3 congruent sides.
If there's a right triangle, does that mean that the other 2 sides are congruent?
Not necessarily. Okay. Now, these 3 words refer to the lengths of the sides of a triangle. They do not refer to anything doing with angles, simply the lengths. Now, what Cressy pointed out is that every equilateral triangle is also an isosceles triangle, because an isosceles triangle has to have at least 2 equal sides. Well, every equilateral triangle has 2 equal sides. But let me ask you this question. Is every isosceles triangle also equilateral? No. Because it has to have 3 equal sides, and an isosceles is only required to have 2. Very good. Now let's talk about the words that describe relationships between the measures of the angles of triangles. Okay, the first thing we have is an acute triangle. And it's cute, it's little, shaft. An acute triangle has 3 acute angles. 3 acute angles. And if you recall from earlier this year, an acute angle is any angle from the measure of 1 to 89. Right? From 1 degree to 89 degrees. Well, actually, it can be less than 1, but it's got to be larger than 0, less than 90.
So what's the definition?
An acute triangle has 3 acute angles. An obtuse triangle has 1 obtuse angle. Very good. Why can't it have more than 1 obtuse angle? Thank you. It would not be a triangle. The 3 angles of a triangle are supposed to add up to 180. And if 2 of the angles are larger than 90, then I have too many degrees going on there. So there is only 1 obtuse angle. A right triangle also has 1 right angle. And if you recall, a right angle is equal to 90 degrees. Yeah, you can. It's not going to mess up. And finally, an equiangular triangle. What do you think?
All angles are equal 60 degrees.
All angles are equal, which, as Darian has pointed out, means that every angle has a value of 60 degrees.
Which means it's equilateral.
Not necessarily. If you are told that it's equiangular, then you know they're all 60. Could be 30, 60, 90. Okay?
But if 2 are 60.
If 2 are 60, you know the 30, 60. All right, so we had okay, hold on, I'm coming. No, it's still recording, I think.
No, I don't think it is. The little thing's gone. There it is.
I'm recording.